Hello, we will continue static courses from our channel. Today is the date 1/4/2020 and I will describe you today how to make analysis of a truss. Truss is a type of structure used for roofs or bridges. Maybe it has a complicated shape like this, okay, or it's very easy, we don't know. Initially we will start from such an easy truss figure actually, and here assume that there is a simple support, assume that there is a roller support, and there are some loads on it. Okay, how to make analysis for such a truss that we will see today. In roofs also, maybe let's say this is a bridge truss where this under part, lower part, is connected to the deck of the bridge, and the deck is carried by means of this truss. Okay, here easily, while modeling this truss system, the supports are introduced here and here. Easily we introduce one of them as the simple support, the other one as the roller support, where it is free to move in horizontal direction. Okay, this is the easy way of modeling, and we can apply loading like this. In the problem set you can see some of the problem set. Which one? Problem set 2 from 12 to 16. Please try to solve these problems yourself. Before solving the problem, first listen this simple lecture. You will use while solving the problems. One of them is the joint method. The other one is the cut section. Okay. Joint method is our first method that to apply on truss systems, and let's apply onto the problem. Which problem? For example, let's take this bridge problem. Why not? Yes, consider such a bridge have some 3 segments between 2 points. Actually this is called as the span of the bridge, and let's apply some loads like this. Here it is the 10 kilonewtons, this is the 10 kilonewtons, this is the roller support, this is the simple support, and give them some name A, B. So let's introduce some diagonal elements also, because otherwise the structure will not be stable. To make a stable structure you have to use enough number of members, F, G, H. The rule of this stability, this is another section of this chapter, but I will say this later. Let's do now the solve the problem and making the analysis. So first of all, introduce the reaction forces like this. Okay, this is AY, this is AX. So what is this? This is FY. As you see, it is the roller support. The reaction is only in normal direction with the surface of the roller. You see the roller here. Okay, if the roller is somehow else in some other direction, maybe some inclined direction, so it must be in the normal direction with the inclination. Here you can apply the equilibrium equations to find the reaction forces first. Let's give some distances also. Here let's say this is 0.6 meter, this is 0.8 meter, this is 0.6 meter again, this is 0.6 meter again. Okay, so what kind of a triangle is this? You see 3 and 4. You can easily insert these numbers onto the figure easily and try to solve it. Let's first write the equilibrium in x direction, what are the forces? In x direction, what is the force here that I see? A x force. Is there any other force? No, so it must be 0. In y direction, write the forces. Ay, the other one fy, the other one is tan, but in minus direction, so it is 0. Taking the moment with respect to some point, I will use here a direction, a point. Then what is the moment of tan? Tan times 0.6, but in minus direction, because I have taken counterclockwise as positive, so 10 times 0.6 minus 10 times 0.6. The other one, 10 times 1.2. The other one plus fy times 1.8. It should be equal to 0. Gives us, what is fy from here? You see, this is 6. This is 12. So minus 12 minus 6 actually. Then 18. 18 divided by 1.8, which gives you what? 10 kilonewtons. So easily Ay will be also 10 kilonewtons. Okay. So these are the reaction forces. Let's pass to now our topic. Now, what is the joint method? Joint method, you have to choose one of the joint individually and analyze it. Here, if you start to analyze from joint C, what you will see from C point. C has these forces on it. One of them is this. What is this? FCD. I'm taking all internal forces. The forces inside the members are internal forces as tension forces. I am assuming it as tension. It is pulling C point. It means CD is in tension. If CD is in tensioning, so what does it mean? So it is trying to pull C point. Consider yourself between C and D. You are keeping in hand C point, and your feet is also on the uptight is to the D point. So between this and there you are tensioned. What happens? You are pulling C point to yourself. I'm taking CD member internal force as tension FCD in right hand side, as you see. In the other direction, FBC, I'm taking FBC also in tensioning like this. I'm taking FCH also. I'm taking everything in tension, as you see, okay? And after I will try to analyze this C point. But as you see, if you apply the equilibrium conditions like this, how many equilibrium conditions for a point? We have 2 equilibrium conditions. There are 2 equations, it means. This is one of the equations, this is another equation. These are equations, but how many unknowns? Don't you see? There are many unknowns here. This is 1, this is 2, this is 3, this is 4. You cannot solve, or you shouldn't start the solution or strategy from C point, okay? Your solution strategy follows, first of all, an easy point here. Where is the easy one? I see there. This is the B point. Because the B point has only 2 arms, as you see, and easily when you draw the B like this, what you will see, these are 0 members, okay? We call them as 0 force members. Now I know one of them, FBC is 0, okay? Skip it, but there are still 3 forces here, so you cannot solve still by taking 2 equations, 3 unknowns. So start from another point. Maybe it would be better to start from A point here, as you see, or the F point, as you see. These are good points to start with. For example, starting from A point, what you will see? Let's see from A point. A is an easy one. This is FAB, which I found as 0 force member. It is 0. The other one, FAC. Also draw the triangle like this. The other one, what is this? FAH. Okay, and there is the reaction here, AY. What is AY reaction? I found it 10. This is 0. This reaction is 0. We know. And from here you can find easily what is FFH is plus in x direction. I'm writing the forces. The other one, FAC times cosine of this small angle, which is 3 divided by 5, isn't it? Should be equal to 0. In vertical direction, FAB, which is 0, skip that. So let's write FAC, but this time the sign of that FAC, vertical component, must be plus 10 is equal to 0. So this gives us what? As you see, FAC is equal to minus 50 divided by 4, or 25 divided by 2, or minus 12.5 kilonewtons, which is compression. Okay, why I said compression? Notice that I taken everything in tension, so it came out to be minus, so it means it is not in tension, it is under compression. Learn that, okay? The term, one of them is tension, the other one, the opposite of it is compression. Okay, we call it as C, this is T. Okay, so from this, if you know FAC, insert FAC to here to find FAH. So when you insert it, you will find 2.5 times 3 will give you 7.5 kilonewton, which is tension. Okay, by this way you can continue with the other joint. Now maybe you can pass now the C joint. Now we know, because FAC here, if you know FAC, then you can find now FCD and FCH. Now I'm passing to the C point now. Let's write the forces in X direction. Okay, what is this FAC? So let's write first this triangle. It would be very useful for you. Do it every time, 3, 4 and 5. It would be very easy now. FAC, but in minus direction, because the horizontal component, as you see, in minus direction. FAC times, what is this? 3 divided by 5. The other one is FCD, should be 0. So this gives us FCD. What is FCD? FAC times 3 divided by 5, which is minus 7.5 again kilonewton, which is called as in compression. FCD is under compression, it means. Okay, so reasonably it is under compression. You can imagine from this figure, when you apply these forces 10 and 10 here and here, such a structure, what happens? There will be such a deformation like this, and this will be under compression, of course. Okay, consider like this. I am exaggerating while drawing the deformations, but so CD will be under compression. Just try to imagine yourself. Consider such a structure. All the joints are free to rotate and every member are behaving, and so okay, just imagine. Anyway, let's pass to find the FCH. To do this, in Y direction the forces are, one of them is minus FCH, the other one is the FAC, but FAC's this time what? FAC's sine component. So this is alpha, sine of alpha. What is this? 4 divided by 5 this time, and there is no other vertical force in vertical direction, so this should be 0. This gives you what is FCH is equal to minus FAC times this. What is AC? Minus 12.5 minus 2.5 minus 10 kilonewtons, which is in compression again. Okay, now you can continue like this, and you can analyze every point to find the forces in every members. Here it is the long way of finding the internal forces, as you see, and there is also another easy technique to do this, but how can I show it? Maybe we can apply this method also, cut section method. This is also very easy methodology. Now I am showing it here. Okay, in the cut section, what you have to do, it's very easy. Just from one figure you can apply just a cut from somewhere, but every time when you cut you will see only 3 forces there. Then by this way you can solve the problem. I will cut it like this. Okay, cut. You see, I cut it. So when you cut it, what you will see there? Let's draw the diagram again. Figure is something like this. When you cut it, what happens? There is the force here, what? 10. There is at A point what? AY. What is AY? It's 10 again. This is 0. What is this A point? Where is this B? Where is this C? So what you will see when you cut from there, there will be a force like this. What is this? FCD. So you will see here FHD. You will see here when you cut when FHG. Okay, now this is the shape. As you see, there are 3 unknowns. Okay, one of them is this, second is this, third is this, and you will apply the force equilibrium equations for forces and the moment, because it is now a solid body. Now it's a thrust structure one side. Moment with respect to some point, it is easy to apply here to find directly the point FCD force. Moment at H, for example, is 0. By this way, by following this, you can find the forces. For example, let's take this third equation directly. FCD times minus FCD times, this is the length, which is 0.8. The other force is 10. 10 times 0.6 must be equal to 0. Gives you FCD is equal to what? 6 divided this, 60 divided by 8, 30 divided by 4, 15 divided by 2, but minus 7.5 kilonewtons, which is what? Tensioning. Did we found it before DC? Yes, I analyzed C point, as you see, and I found FCD minus 7.5 compression. Sorry, I have to insert here compression. So as you see, it's again compression. Either using this method or this method, you can analyze every structure like this. You have the problems starting from 12 to 16. Please try to solve them yourself. They are a little bit complicated maybe, but you can apply these methods. Okay, this is one part of this truss structures. I will also continue with the truss. What is the truss stability? I would like to also talk about the truss stability easily here by looking to this figure again, and let's also apply what should be the minimum requirement of the stability of a truss. So to do this, you have to check the number of the unknowns on the body. What are the reactions, for example? First, for our problem, reactions. Reaction forces are AX, AY. What is the other one? FY. How many? The number is 3. So we call reaction as 3. What is the number of the members? Okay, members are, as you see, I'm now counting them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There are 13 members. Okay, how many joints we have? Joints, or we call them as nodes also. So let's write J. So joints I'm using 2, 4, 6, 8 joints. Okay, so what should be the condition here? Okay, here it is one of the problem. What should be the condition? Here you have to check what is the M plus R. What is M plus R? 13 plus 3 is 16. What is 2J? This is 2 times 8, which is 16. As you see, 16 is equal to 16 means what? It is statically, let's take the camera here. It is statically determinate structure. First of all, let's say it is a stable structure, stable and statically determinate. You can solve the problem by means of equilibrium equations. Total summation of F and total moment should be 0, 0 is enough to solve the problem. I will write here some of the conditions, then you will see when what happens M plus R is bigger than 2J. In this case, again, it is the stable body, stable, but statically what? Indeterminate. You cannot solve this problem easily by means of the equilibrium equations. Indeterminate. So what happens when m plus r smaller than, this must be only single, bigger than this, smaller than 2j, it is unstable structure, okay? You don't need to solve such a problem because it is unstable, it will collapse, okay? So you don't need to solve it. The same is valid for three-dimensional structures, but in this case, what will happen? In 3D structures, you have to apply the rule like this: m plus r must be equal to 3j for what? Statically determinate structure. If m plus r smaller than 3j, it is again unstable. Okay? You will see all this when you try to solve yourself the problem. Please try to solve this 12 and 16. And next time I will continue with some other topic. Okay, this is what I can explain about the truss structures. Maybe if I can do, I will also solve a problem for you at another video. Thank you very much for your listening.